In Chapter 9, Section 7, you're going to talk about linear, quadratic, and exponential models. Now, you've already learned all about all three of these different models, but now what you're going to get is you're going to get a set of data, and you need to decide whether it's linear, quadratic, or exponential. So take a look at the three examples. Linear means it's a straight line. Quadratic means it's a parabola. Exponential means that it just goes up. It goes up real fast, but it always has like it's called an asymptote. It's something that you approach, but you never go below. You've studied all three. Now let's kind of put all three lessons together. Problem 1. Plot your points, and then we're going to see if we can tell which one it is. So 1, 3 is here. In problem 1, we're going to plot your points and see what shape we think that it makes. So 1, 3 is right 1, up 3. There we go. 0, 0 is right in the middle. Negative 3, 3 is to the left 3 and up 3. Negative 1 is to the right 1 and down 1. And negative 2, 0 is to the left 1 and down 1. And negative 2, 0 is to the left 2, up 0. So can you see how these points together, if you were to connect them, they would definitely take the shape of a parabola. That means this one is quadratic. Let's take a look at part B. 0, 2, negative 1, 4, 1, 1, and over 2, up and a half. Can you kind of see how this shape goes down? But it's not looking like it's going to go back up. Almost looks like it's going to start leveling off. This one, it's not a straight line. It doesn't go back up, which means you got exponential. The next one, negative 1, negative 2, 0, negative 1, 1, 0, and 3, 2. Take a look at those points. They make a perfect line. This one is linear. Now we could do that again. If you think you need the extra support to do that, please do so. This one you should find to be exponential. This one you should find to be quadratic. Okay, so if you need some extra support, do those two. Now this big area down here, we need to make sure that you understand how you can look at just an XY chart. Okay? So this one is how to look at a chart and decide. So this way you don't have to graph them, you just look at your chart. Take a look at this first chart. Can you see how it skips by like plus and minus on this side and plus and minus on this side? That's what we call a common difference. This means that it is linear. Okay? So this little section is linear. It has a common difference. Take a look at the next one. As this one goes up evenly, this one gets multiplied on this side. Or, if you need to see it, it's getting divided by on this side. So over here we have addition, subtraction to make a linear. Over here we have multiplication and division to have a common ratio. We've talked about that before. To make it exponential. Now take a look at this last one down here. You should notice that no, they are not the same when you add and subtract them. Let me kind of cover that up for a second. They're not the same when you add and subtract them to begin with, but they also don't multiply. When that happens, when the adding or subtracting isn't the same, or the multiplying or dividing doesn't work nicely, it's not linear, it's not exponential. What you need to do then, okay, what you need to do when it's not adding or subtracting or multiplying and dividing, that means it's not linear, not exponential, you need to find what's called the common difference. So you say, okay, well I see this the first difference. If I look at those, I can see it from one to the other. It goes up 4, up 4, up 4. When the second difference is the same, that means it's quadratic. So let's apply this to some of the charts. Take a look at problem A. These are going up by ones, so we can compare this side. See how it has what we call a common difference? That means it's linear. Look at the next one. So right here it doesn't have a common difference, and it's also not adding or subtracting, so they checked the second. So they did, well I see that's down 0.5, this difference down 0.5, this difference is down 0.5. Okay? What that means is that the second difference is the same, which implies that it's quadratic. Now I want to talk about this linear one for a second. I want to go back all the way to when you had Mr. Lankus and you were in chapter 5 talking about straight lines. Do you guys remember that the slope are the y's over the x's? The change in y over the change in x? Can you guys see that this one is a -4 over a +1? So the slope of this line would be a -4. And that's just a little bit of extra. You don't have to find that, but if this was on a keystone, you better be able to. Let's look at the got it. Let's list our x's from lowest to highest, the x's from lowest to highest, and then let's list the y's accordingly. 0.5, 1, 2, 4, 8. Can you see that each one, it's not getting added the same, but each one's getting multiplied by 2. What that means is that this one's exponential. Now you know what you should be able to do for me. You should be able to tell me what the base is. We have done this. The base is a 2. Just a little bit of a review. Let's move on to a real life situation and decide what model would fit it best. This data shows the value of a used car over time. So you can see how much, see what they paid for their car when it was brand new? They paid $12,575 when it was new. And after 4 years, it's down to $7,500, or, $7,540. What is the best model? We can do exponential, quadratic, or linear. So the first thing we're going to see is let's test the adding and subtracting. Okay? So we'll do from here to here, it goes down by 1,510. From here to here, it goes down 1,315. From here to here, it goes down 1,230. And from here to here, it goes down 980. These are clearly not even close to being the same, so this is not linear. Let's check out the second difference. From here to here, it actually goes up how much? 195. From here to here, it actually goes up 85. From here to here, it goes up 250. Now these are also not the same, so it can't be quadratic. So what we're going to do is we're going to test the exponential. In order to test the exponential, you take the y and put it over the y previous to it. So we're going to take 11,065 and we're going to divide it by 12,575. And then we're going to see if that is equal to or very close to the next one. 9,750 over 11,065. And then we're going to see if that's equal to 8,520 over 9,750. And we've got one more to test. 7,540 over 8,520. And we're going to see if these are anywhere close to each other. So you've got to get any type of calculator. It's really not, you don't need a fancy one for this. You're just going to divide. 0.065 divided by 12,575, and that's approximately 0.88. Now let's try the next one. 9,750 divided by 11,065. That's also approximately 88. That's good. That's what we're looking for. Let's try the next one. 8,520 divided by 9,750. That's about 8.7, so not perfect, but pretty close. And now the last one. About 88. So you can see that these are very close to each other. We're going to call it exponential then. Now we can make our equation. You have learned this. Remember, it's y equals ab to the x. So this equation is going to be y equals, well, how much did it start at? 12,575 times b, which is 0.88, because that's the increase, to the x, and x is time in years. That is pretty good. Now what we're going to do is I'm going to teach you how to get the perfect answer in your calculator. Alright, so you're going to go to your calculator. Let me zoom out so you can get a better look at the whole calculator. And you are going to go to your Stat button. You are going to go to Edit, number 1. You are going to clear any list that is in here by going up and hit clear. I'll do that one more time. You would go hit up, you'd hit clear, then you'd hit down. And we're going to type in all the x values here. Ready? So 0, 1, 2, 3, 4. I'm hitting enter after each one, and all the corresponding y's. So 12,575, 11,065, 9,750, 8,520, and 7,540. So we get all in there, and now what we're going to do is you're going to hit the Stat button again. This time you're going to go over to Calc, and you're going to find, hopefully somewhere in here, an exponential regression. See how it's the number 0? Since it's exponential, we're going to hit enter, and we're going to hit enter again, and look, it tells us exactly what our equation should equal. Okay, so in the calculator, it says that A is 12,578, which is pretty darn close to what we have, and it tells us that B is 0.88 if we round. So we got a pretty good answer, especially since it's almost exactly what we got in our calculator. So our calculator answer is 12,578 times 0.88 to the x. And what that means is that you could take any of these x values and plug them in, and you'll get an answer. For example, let's plug in 4 and prove that we will get this out. Okay, so I'm going to use my calculator answer because it's a little more exact. So if I do y equals 12,578 times 0.88 to the 4th, watch what I get. Alright. There, that looks pretty good. So 12,578 times 0.88 to the 4th. Look how close it is to being exactly what we got for our car value. Pretty neat. Alright, now if you wanted to take the time to graph these on problem 3, I hope that you are capable of this. You would notice that they take a very slight looking J as you graphed the numbers. Got it? Number 3, we'll do in a separate video.